All right, all right, all right. Guess who's back again? This is Mr. Giancarlo with What's Up with Giancarlo. Now, some of the old videos, 7th grade math, we're rocking back with 6th grade math now, okay? We've got topic 4, lesson 7, simplify algebraic expressions. Yeah, I can combine like terms in algebraic expressions. So this is a very important lesson, okay? Please take notes to the best of your ability, okay? Yeah, yeah. All right, let's get started. Woo! Yeah, let's get started. Yeah. So, we are rocking with like terms. Like terms are when you have the same variable raised to the same power. That is very important. Again, I can't stress how important this lesson is. So, same variable raised to the same power. All right, let's look at A. 4x and 5x. Same variable raised to the same power of 1. It's there, you just don't see it because there's no need to put the power of 1. So 4x and 5x, good to go. Those are like terms. You can combine them depending on what the sign is, all right? Whether you go up, down, turn over, go around, whatever, all right? You can combine them because they're like terms. Letter B, we've got 2x squared and 6x squared, okay? Variable, bada bing, bada boom, same thing. Exponent, 2, bada bing, bada boom. Again, like terms, okay? Same variable, same exponent, boom, you're good. Combine them, get them over with, all right? Letter C is where we start seeing some non-like terms, okay? Big red X. 4x and 5y. They might have the same exponent, but they are not the same variable. Therefore, you cannot, absolutely not, combine these terms because they are not like terms. All right? Letter D, 2x and 3x squared. So, same variable, cool beans, we've got one of 2, but not the same exponent, okay? So, we cannot combine them. It does not work, okay? Please pause and take these notes. Write down everything you see on this slide, okay? All right, cool. Yeah. Example 1. Combine like terms with integer coefficients. Terms that have the same variable part, such as y and 2y, are like terms. To simplify algebraic expressions, use properties of operations to write equivalent expressions that have no like terms and no parentheses. A teacher used tiles to model negative 2c plus 3c minus 5 minus 4c plus 7. Simplify the expression. Ooh, models. Cool. Not really. I don't like models. All right? Whatever. They show you how to you separate them, blah, blah, blah. Cool beans. Not really. I am going to show you how to group up like terms, put them together, and then solve it that way. So first thing I do is circle a set of like terms. So I'm on green. I'm going to circle negative 2c. I'm going to circle positive 3c. And I'm going to circle negative 4c. All right? And I have no more like terms with the variable c. Now I'm going to underline the other like terms. I have the constants. That is a number without a variable. So I have a negative 5 and I have a positive 7. Okay? Notice what I did here. I circled the signs in front of them. That tells me what to do when I write it out. Okay, so let's start off with the variable c. I've got negative 2c plus 3c minus 4c. Okay, now let's write out the other expression. Negative 5 plus 7. Okay, so negative 2c plus 3c. So I'm adding with different signs, so it's really 3 minus 2 to get 1, and I take the sign of the bigger number, which is 3. So I'm left with 1c, or just c. How many are there? Just one of them. Okay, I don't need to put the 1. I only see 1c. That's all I have to put. All right, and then minus 4c. So I have 1 minus 4, and then the variable goes for the ride. So 1 minus 4 is just like 4 minus 1, which is 3, and then keep the sign of the bigger number, which is 4. So I will end up with negative 3c. All right, now let's move over here. Negative 5 plus 7. That's really the same as 7 minus 5 to get 2, and then I keep the sign of the bigger number, which is 7, so it is a positive 2. So after I do everything that I can do for the two expressions, I just put them together. Negative 3c plus 2. I know it's plus because it's a positive, and then I'm done. And when I say put them together, I mean put them together in an expression. I cannot combine them because they are not like terms. This is as far as it goes, okay? Let's move on to example 2. Yeah! Ooh, yeah! Example 2, let's go! We're almost done! All right. Oh, I lied. Tricked you. So we've got all of these little try-its for you to do. So go ahead, pause the video, and work on them to the best of your ability. And then if you have a couple problems, then you can just continue to watching the video and watching me do it. Okay? All right, let's get started. I'm going to go to green, and then I'm going to circle like terms. So I've got 4x, and I've got positive 4x. Then I'm going to go to blue and underline the other pair of like terms. I've got positive 3 and negative 1. Now let's work them out. 4x plus 9x. And I've got 3 minus 1. So what is 4 plus 9? 13. X. X comes along for the ride, okay? Now what is 3 minus 1? It is 2. So let's make this expression. We've got 13x plus 2. Boom. And we're done with A. Now we move on to B. We have 2x. I look around, look at all the other terms. I don't see any other x's, so I'm good for that. Now I'm going to the y's. You wanna fix all the variables first. You want to figure out all the variables first. So now I have 3y, positive 3y, and I have a negative y right here. All right? Now I'm going to go red, and I'm going to do a square. Okay? This is what you guys can do with a pencil. You don't need all the different colors. You can go circle for some like terms. You can go underline for some like terms. And then you can do a square. If there's more than 3 pairs of like terms, try a triangle or try a different shape. All right? But here's the other constant. Okay? So let's start working these out now. I've got 2x, and that's all I've got for x's, so I can move on to the y's. I've got a positive 3y minus y. And is that any y's? Yes, it's 1y. We don't need to put the 1 there. There's 1y right there. We know it. The 1 is imaginary. Okay? Now let's work on negative 11 plus 4. So 2x, we do nothing with it. 3y minus y, that is 3 minus 1, we get 2y. Negative 11 plus 4 is really just like 11 minus 4, and then you keep the sign of the bigger number. So 11 minus 4 is 7, and then the bigger number is negative, so I make it negative. Now let's write our expression. 2x plus 2y minus 7. Okay? Let's try and make a nice little rectangle, nice little box around this. Boom, that's looking good. Looking good if I do say so myself. All right, so now letter C, we've got 4x. I don't see any other x's. We can move on to the y's. I have positive 2y. Don't see anything else. Move on to the constant. Boxed up. All right, so is there anything I can do? Are there any like terms I can combine? No. So what I'm going to do here is just rewrite it, and that is my answer. Sometimes that's the way the cookie crumbles, okay? It just works like that. Box it up and ship it out because it's ready to go, yo. It's ready to go, yo. All right. Last but not least, letter D. We've got 11x. We've got negative 4x. We've got nothing else with x's. So now we move on to y's. We've got negative 15y and we've got positive 2y. Excuse me. Now we've got the constants. 13 and negative 6. Now that we've taken care of all the like terms, let's start working it out. Let's start solving. We've got 11x minus 4x. For the y's, we've got negative 15y plus 2y. And for the constants, we've got 13 minus 6. All right, so let's get going. 11 minus 4 is 7. So we get 7x. I can't do anything else, so let's move to the y's. Negative 15y plus 2y. So that's really 15 minus 2. Keep the sign of the bigger number. So we get negative 13y. And then we're done, and 13 minus 6 is 7. So for our final answer, we get 7x minus 13y plus 7. A lot of 6s, a lot of 7s. You guys must be going insane right now. Now we are finally done with example 1. Let's move on to example 2 for real now. All right. Example 2. Simplify algebraic expressions with fractions. A new hiking trail includes 3 sections of an old trail. There is a flat section, a hilly section, and a winding section. The park ranger marked the sections of the trail in relation to the length of the flat stretch of the trail, which is n kilometers. What is the simplified expression that describes the length of the new trail? So, this is looking like perimeter. We have 2n plus 2/3 plus 2n plus n plus 1/2. Okay? That is our expression, and I've got it written down right here. So let's do our thing. We circle 2n. We circle positive 2n. We circle positive n. Now we underline the constants. We've got positive 2/3 and positive 1/2. So the n's are very easy. We've got 2n plus 2n plus n. I'm just going to solve that real quick because it's so easy. 2n plus 2n is 4n plus n. Give me 5n, bruv. Let's go. Now we have 2/3 plus 1/2. I can't add these fractions together because I do not have common denominators. So how do I make common denominators? By finding the least common denominator, LCD, or what we did in lesson 2, least common multiple. Okay, so the least common multiple of 3 and 2 would be 6. So I'm going to have 6 as the new denominator. So I'm just going to put that down here. And how do I get From 2 to 6, I multiply by 3. How do I get from 3 to 6? I multiply by 2. So whatever I do to the bottom, I must do to the top. Okay? So I've got 2 times 2, 4. 1 times 3, 3. Here it goes again. 4 plus 3 is 7 over 6. Hope you guys are enjoying yourselves. At least I'm not there to hear the annoyingness. And 7 over 6 is 1 and 1/6. So our expression will be 5n plus 1 and 1/6. You can box it up, ship it out, because it is good to go. Good to go. Way better. That sounded way better. All right. Example 3. Simplify algebraic expressions with parentheses and decimals. Use properties of operations to write a simplified equivalent expression without parentheses. I've got 5 on the outside and then times in parentheses negative 17x plus 9x minus 10.5 and parentheses. So I wrote it out to make it look better. So we've got like terms, boom, right here and right here. And then we've got this constant all by itself. So let's rewrite this after solving the like terms. So negative 17x plus 9x is basically 17 minus 9, which is 8x. And we keep the sign of the bigger number, so it's negative 8x. Then we have minus 10.5 because we don't do anything to it. All right? Now we are going to distribute. We have to distribute the 5 to both terms on the inside of the parentheses. So we've got 5 times negative 8x, and then we've got plus 5 times negative 10.5. Okay, so what is 5 times negative 8x? It is negative 40x. What is 5 times negative 10.5? It is negative or minus 52.5. Okay? Box it up, ship it out. It's good. All right? We've got one last try it to do, and then we are done. Okay? So go ahead, pause it, try this on your own. Should have been enough time to pause it. So we've got a t. Give me a t. Give me a positive 3t. Woo. And we've got a negative 4.5, and that's it. So let's rewrite this. We've got negative 2, and then in parentheses, t plus 3t is, that's really 1t, so it's 4t, and then little curve, make it look nice so it doesn't look like a big plus sign, and then we have negative 4.5. So we must distribute the negative 2 to both terms on the inside. So we've got negative 2 times 4t. And then we have negative 2 times negative 4.5. So what is negative 2 times 4? It is negative 8, and the t comes along for the ride. Negative 2 times negative 4.5 will end up being positive 9. Negative times negative makes it positive. All right? Box it up, ship it out, because it's good to go. It's good to go. It's good to go. All right? And whoopity-doo! We're done here. All right? If you've got any questions, hit me up in the comments. And as always, if you're watching the video, you're a part of the class. See y'all next time, everybody. Later.